So there was one in class grade. Essentially,
all right, let's turn our attention now to solving some equations. And the very first one we want to look at is one that I think that like maybe would be prerequisite. I tried to make it a little bit tricky, but like theoretically it's still something that could have like been on your summer packet. So give that a try. Check with the people at your table, and we'll come back together in like I don't know, 60 seconds or something, whatever it takes you.
Wait, is this on
You don't need, yeah, I think the one-to-one property is on your sheet too, actually.
Okay, yeah, it's the last thing on there though.
Oh, it's on the sheet? Oh, yeah.
I think so. Right now, don't like labor over it too much. Solve the problem, and I'll come back. We'll talk about what the things at the top say in a minute. And when you get it, let me know. I'd love to hand a pen over to someone.
Don't say it out loud.
Yeah, I'm gonna hand it to you. I think it's on there, right? Yeah. It is. It's on the bottom. You don't have to write that down. I'm on the punch. Quick and smart are not the same thing, but she is required. Yeah, don't look up and see what Rachel's doing, okay? Unless you're done and you want to spoil it. You know, don't.
It worked.
Yeah, this part should be like somewhat reviewed. How'd you do? I mean, all you can do is put it in and see if it works to know whether she's right or not. Did it work? Like, is it true that 20 times 1/2 to the 6 is 5? I have a question for you. Why, as you're doing this, like, why can you do this? I mean, maybe you've done this, and that's obviously you know how to do it. But I'm wondering, like, what allows you to do that? To like be like, these have the same base, therefore the exponents must be the same. Like, if you see, I think like one way to write this up here is that if A equals B, so A, what are we doing? Here we're doing like, you want to, let's write like x to the A, x to the B. If this is true, then this is true. And if this is true, then this is true. This is like biconditional. It's a two-way implication. If you have this, then this is true. If you have this, then this is true. That's what this is saying here. This part up here. Okay. Cool. It's not necessarily given that that's true, though. I'm thinking of something else in my mind here. What about like if I had this? Okay, this I'm like happy with. I think because you told me you are apparently. And now I'd like to ask this in my mind here. Like, for instance, I just want to make sure you're clear on like what am I allowed to do to both sides of an equation and have it be an if and only if, right? So the question is, can I draw an arrow here, and if so, how? And
We used to do.
I mean, does this work? Is it true that? I mean, which way does the implication go? Here it's both ways. If this, then this. If this, then that. Both ways. Talk to me about this, though. Raph, you want to take it? Okay. Okay. Yeah. So you want to take that too?
You can go from the right to the left because if you know that like if you know that the number equal and their squares will be equal, and
like this?
yeah, but you can't
Okay.
go the other way because what Rocky said.
Okay, but you can't go the other way because of like those. All you have to do is give a single counterexample, like Rafi said, and then you'd be good, right? Yeah, but do you agree with it? It does imply going this way. We're okay. So what makes this? So I'm just saying. I just want to make sure you understand that. Like, it's actually not a trivial property. Like, we're all right that this works. we're all right that it works, but I just want to like stop and appreciate the fact that it works is not necessarily like a given. Some things you do to both sides, that doesn't seem to be true for, right? So like when does this work and when doesn't it work? There's something special about a function that you might apply to both sides in such a way that this has like a two-way implication. Yeah, it's only biconditional if the function that you're applying on both sides is, oh, it says up at the top, 1-to-1, right? And it just so happens that the squaring function is not a 1-to-1 function. So that's part, I don't know if you've ever actually had that conversation before, but like the reason you can do this with both exponents and with logs is because they're 1-to-1 functions. Okay, that's the reason, that's why it says 1-to-1 properties. Okay, just like if you add 5 to both sides of a function, that's a x plus 5, that's a 1-to-1 function. That's why that works. Okay, maybe you've never thought about in those terms, but all right. Sorry, I get a little excited. Okay, let's go. Let's solve something that's a little trickier that might not have been seen here on the course. I'll do the first step for you, just because like that's the kind of guy I am. All right, there you go. Yeah, that's just my gift to you right there. Okay, but then what? No, I got more for you. I'll help you a little bit through this one. Point you in the right direction, maybe. Because this is tricky. I don't know what to do. I'm going to suggest like a small rewrite, though, maybe. How about, I think you're going to be fine with this. Are you fine with that? Does that suggest anything that you might do? I don't know. The thing that makes me think of is like if you were doing m. This kind of like feels like this equation to me a little bit. Yes? Does it to you? Doesn't it feel like that equation a little bit? All right, if you agree, then what would you do to solve the m equation? What might you do over here in the bubble? I wouldn't do that. I might. I mean, you're welcome to. What would you do? You might multiply through by m. Do you agree? You might be like, I don't really like fractions that much, or I don't know what you might say. So if that's true, then maybe multiply through by e to the x, maybe, just for fun. If we do that, we get what? E to the x squared, which we could write as e to the 2x if we want it. But actually, maybe we don't want. We'll see. I don't know. I think maybe I like it this way. Minus 5 equals 4 times e to the x. Do you like that move? And then actually maybe it would be good to like in parallel solve this m problem over here just to like think about what would you do next? You'd multiply through by m and then what? What was your plan over here in the bubble? What was your plan in the bubble? Multiply through by m, then yeah, then you were going to do what? Yeah, you're going to do some stuff and factor maybe. Wait, really? Let's just see how this goes. I would maybe move things over to one side. Right, this has been... And then, yeah, I might be thinking about factoring at this point, right? Aren't we looking at the equation m squared minus 4m minus 5 equals 0? Yeah? Isn't that really what we're looking at? In fact, if you want to work with that equation instead, you may. And then afterward, put in e to the x. Okay, so talk to me then. What do we... So we're going to factor this with like an e to the x. Okay, I like that. And then what goes where? Minus 5 and minus 1. Positive 1. Does that work? Is this still okay for you, people out there? Okay. So, therefore, e to the x equals 5, or e to the x equals -1. But keep in mind we're not done at this stage, though. We still are looking, we're on the hunt for x, aren't we? I mean, that's the goal of this problem. So, what's x? Yeah, we can rewrite this in logarithmic form to get ln 5. Or, over here, what would that be? X equals...
That's not possible.
Yeah, it's maybe not possible. Explain.
You can't have a positive to the power of something even.
Yeah, and I like what Peter's saying. Some people are like, well, the argument of a log can't be negative, but you don't have to even talk about logarithms to me to justify why this doesn't have an answer. All you have to do is say what Peter said. Say it again, Peter. What did I say?
A positive number to any power cannot be negative.
Right. Yeah, I mean, this doesn't make sense. Or you could think, about the graph of e to the x, right? And you could think about that as a function. What's its range? Isn't it 0 to infinity?
Yeah.
The range of that function? -1 is not in that range. Okay, so. Yeah, I mean, yeah, absolutely. Yeah, it's an extraneous solution that arises from it's an extraneous solution that arose from the algebra, but doesn't actually solve the equation. There's no real solution, I guess we should say. All right, so the answer we have is, we're just going to box it now, ln 5. X equals the natural log of 5, which you can approximate in a calculator, but we're just doing this without a calculator. It's like 1 point something, right? You know, something. 1.61? Sweet, thank you, Matt. All right. So do you like this technique? I mean, the thing that this makes me think of, if you know, the thing that is maybe most recent in your mind that feels like this maybe, is when you're factoring like something that has the quote unquote quadratic form. Do you remember that? Like where you have like x squared minus 5 times x squared plus 1 as the factorization of some quartic, maybe. And we're like factoring as if it's quadratic, but it's actually not. That's kind of like what's going on here. This has like a quadratic form that you need to like be on the lookout for. It's not the last time this will come up. We're going to see it again this year. Like maybe even like, I don't know, right now. Like, come on. There's another one. There you go.
That's like on a
No, I mean, not, no, like, sorry, that might have been a spoiler, but like, it's a very similar problem is the point. And I want you to just try practicing the mechanics. Try practicing the mechanics involved. Let's do it.
4 years ago. Algebra 1.
I know, everything in math comes back to haunt you.
Yeah.
So give it a second.
Wait, I don't like these twos and these. Like,
Sorry.
They're just,
I know.
don't.
Hold on. 2 to the negative z dash. So that's like 2 to the 1 dash of z. Okay, I'll write that. 1 over z. Yes, but kill somebody right now. It's closest to you. Why do you want to?
He's still talking.
What did you get 2z? That's essentially 2z squared. But I don't
Now it's 2z to the
2z to the z power is 2z squared. Think about it. Twice a number times itself. That is 2z squared. 2z, he's talking about 2z to the z power. Oh.
Is that a 2 or a 2?
Oh.
Like, I did something wrong.
That's what I did. That concept.
I mean, I multiplied by 2 to the z again. Just like we multiplied by e to the x or whatever it was last time. Yeah, then what? Then what? Let's do it. There's no quadratic that can be can escape from your grasp. You can do this. We can do it. All right, here it comes. The thing that we're looking at, if you want to like temporarily put an m there or whatever you like, whatever letter you like, the thing we're trying to solve, the quadratic, is m squared minus 10m minus 1 equals 0. And so what does m equal? Well, it equals negative b plus or minus the square root of b squared minus 4ac all over 2a, or just 2. And by m equals that, we mean 2z equals that, okay?
But I never. I didn't use that.
We'll see if we get the same answer. I mean, I don't think I'm going to be able to factor that, just like the last one. This comes out to, let's see, 10 plus or minus 2 root 26 over 2. So is that 5 plus or minus root 26? Okay, anyone? Do you like that? First of all, let's agree that we're in all the same place. You sure you like that? I just want to make sure you understand that the quadratic kind of thing happening last time, well, I mean, it could result in a quadratic like this. That's okay. And then what's our answer? Remember, we're not done.
Z equals log 2 of 5.
Z equals log base 2 of 5 plus or minus root 26. Is that good? What do you say? No, 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 no. Speak up. We need you. Why? Do you agree with Noah here? That we can actually throw away, we actually need to throw away the minus root 26 solution. And actually, we could have said that even back here, couldn't we have? We could have been like, 2 to the z has got to be something positive. Okay? And 5 minus root 26 is definitely negative. Can you convince yourself of that? Okay. So there it is. Only one answer. It's kind of messy. If you want to approximate it with your calculator, you could. Actually, we might be able to do it in our heads. That's like roughly 10, isn't it? So log base 2 of 10 is like, I don't know, 3 point something. Yeah? So that's what I think it is. X equals 3 point, z, excuse me, equals 3 point something, right? But we'll leave it that way for now. We good? Are we blowing your mind? Is this fun? Okay, hopefully this is enjoyable for you. Okay, let's turn our attention to an equation that might involve like the word log. Ready to go. Let's try this first one. I want to like hear your thoughts about it before I just show you the way I'm going to be thinking about doing it. Maybe it's, the first one's kind of a little bit simpler. I don't know. Yeah. So how do we do that? I hear some interesting conversations out there. So, someone might be like, well, let's see. We got 2 log t equals 2. And so log t equals 1. So t equals, that's a common log, right? So that's t equals 10 to the first. And then someone else might come behind and say, what? I heard some people saying it out there, whispering, mumbling about, yeah, am I here? So wait, say it again. Oh yeah, sure, yeah, absolutely. And then, yeah, and so what would that give you? You mean right here, right away? So what would that give you? What equation? Yeah, t squared equals 100. All right, so if you, instead of applying this property which you think you love, instead of applying this property initially and then running from there, you could apply, just take this from log form and right away put it into exponential form, right? How does it go? 10 to the 2 equals t squared. Isn't that what, like, take it from log form, put it into exponential form? And what does that reveal? Yeah, that t equals positive or negative 10. So what happened? No, negative 10 is a perfectly good answer. If you plug negative 10 in, doesn't it work? Negative 10 squared is 100. Log of 100 is 2. So what gives?
When we solve the true logs, you assume that t squared is positive. When you look at it as 2 log t, you no longer had the squared acting as a filter.
Yeah, this. Oh, I like that. Say that again, Jeff, because I think the ladies in the back were chatting about something. I don't know. They missed it. This is like gold coming from Tim. Go ahead, say it again.
Log t squared into 2 log t.
When we did this.
Yeah, you removed the filter because by having log t squared, whatever you put into the t slot, it must come out must be positive.
Okay.
It's squared, therefore it could be any number.
Okay.
Whereas if you write it as 2 log t, you have to have a positive t. Otherwise,
Yeah, there's an assumption that as we went from here to here that t is positive, right? Those are equal if t. Wait, I feel like I've had this thought before today. Yeah. Yeah. Hey guys. Well, that's a good question. Are these equal? So what's the assumption as you go from this form to this form? The assumption, we say when I was just talking about, the assumption is that t is positive for this to be true, right? And like I said, that rings a bell. Do you remember the warm-up today? Like, I feel like we've thought about this before. These aren't equal is the point of the warm-up for negative values. So it's not true that you can put a negative value in here. That's why if someone asked me to solve this equation right here, 2 log t equals 2, I would give them the answer correctly, 10. But if someone asked me to solve this equation, I'd say plus or minus 10. I hope you appreciate the difference.
So
yeah.
they are equivalent but not equal.
They're only equal for positive. The thing is, someone gave you a property like that at one point in your life, and it said, provided that t is positive. And you just ignored that probably. Okay. Just want to make sure like we're bringing that nuance right to the surface. Try this one when you're ready. If you haven't already. You do it?
Do you have to like write the large decimal?
No, no calculator or anything today really. Alright. How's this going for you? Did you do it?
Yeah.
E squared? Okay.
Or
I'm seeing what I did here and realized is that there might be something here.
or 6 roots of e.
Here, wait. Can I show you?
Yeah, I got e squared.
No, real quick.
Yeah, I got e squared also.
It's not
Everyone here got e squared.
What'd you get?
I don't know. It's not e squared.
Well, it's really good 6.
Once you get back there,
Over E12 squared.
once you get back there.
So, elements E6 and
Huh? 100? Yeah.
well,
Yeah. 100?
No, you're not missing anything. Right.
It could be negative.
I don't think that works.
All right, I think I'm ready. Are you? I hear a lot of people who are done.
here, Judah, you probably know.
Get x to the 6 equals e to the 12. All right, so then what?
Is that right or wrong?
Yeah, Matt?
Find the 6th root.
All right, so that's e squared.
I was.
What'd you say, Matt?
Would be plus or minus.
Wouldn't it be plus or minus e squared? People who wrote just e squared? When you take a 6th root, or like on the previous problem, if you take a square root, then maybe we need that there, right?
We figured it out. We didn't realize it was
Oh, okay.
Are you ready?
Yeah, I guess.
All right, that does. I see that. Plus or minus, though. 100 for you. Yeah. Then what? Say what?
How will you know where the ln on the outside rather than
All right, so you're good here. I just moved things over. And then here, I just rewrote this in log form, right? So this says e to the 12 equals x to the 6, right? That's log. That's exponential form.
I did the 12 on the other side and then put the 6 in front and then I divided it. So you got 2.
Yeah, as soon as you drop the 6 down to the front, you've made this. You've made that mistake. Hey guys. All right. So I hope you see. Even though we just like talked at length about the first example, some of you still kind of fell into the trap on the second example. When doesn't this happen? I mean, when don't you have to think about it?
When the exponent goes down.
I mean, when can you do this more cavalierly, maybe? I mean, when you know it's positive? When are you not going to get a plus or minus there? When the exponent is odd. Yes, good. Right? So, anyway, I just want you to like be thinking, right, about this. Don't just like apply the properties like a hammer. I think we have time for one more. Let's do this one here. Let's see how this one rolls for us here.
Really? Right? That's a trap.
Now keep in mind, I'm thinking that you know all the properties of logs and exponents that we talked about, that we handed out on that sheet yesterday, just from last year. So I even think that maybe this is a problem of a kind that maybe you might have seen before. I don't know. So my instinct on the left side is to do what? What's your instinct? We got two logs with the same base, so yeah, we can multiply the arguments. It's ln of 3x minus 2 times x minus 1 then inside. And over here on the right side, I'm going to do something that like seems like a little bit rash after the thing we were just doing on the previous slide. This seems like, wait a second. So we'll do that. We'll turn that 2 ln x into ln x squared with just like a note of caution, right? We'll just be like, that might have just introduced another solution, maybe. Okay. Right? Because we know that could have maybe introduced
Oh,
another
and then
solution.
they're the same.
Yeah. I mean, that we just have to be careful at the end that any solution we have, really does
Check
work.
if it's positive.
All right, so if we have, this is now we can apply the one-to-one property again, the one for logs. That means that we can set the arguments equal to each other. And at least for now, we need to like think about where we're at when we're done. But at least for now, we have an algebra 1 problem. So let's solve it.
What about algebra 1?
You have to.
I mean, there's some work to do here, right? What is it? 3x squared minus 5x plus 3 plus 2. That's what I meant by that. All right, how'd you do? Does this factor nicely? I got a 2x maybe then, hopefully, and an x. Wait, whose is this? Wait, hold up. So what do you get? 2x minus 1 and minus 2. So x equals. Do both answers work? Check your answers in the original equation.